Hello, welcome all. Continuing the Rota Academy. Today I will be discussing the session 5, and that will focus mainly upon the basics of the rotablation technique. So we all are aware that how to start the rotablation on the basis of image. So once we are ready to go for the rotablation, then we should keep some important things in our mind. First, in this session, I will discuss something about the concept of rotablation, some about what are the indication, limitation, what are the hardwares, what are the protocols, and what are the basic technical aspects. So we just thinking about the indications. Once we have seen a moderate to severe calcific lesion, and that can be a de novo lesion. So in initial trials, in like airbag trial, cobra trial, or dart trial, it was seen if you don't have a highly calcified lesion, then there was no benefit of rotablation. But later on, it was seen if it is for a fibrocalcific, morely calcific, then the benefit of rotablation was seen. And there were two strategies. There was aggressive debulking, and there was a plaque modification in which the burr size to artery was taken to be less than 0.7, and it was compared with more than 0.7. So there was no use of taking the larger burrs. So over the time, now we are taking the lesser size burrs to modify the plaque, to modify the calcific plaque. There were few trials for the restenosis also, but it is not that a great indication for ISR, although we do the rotablation sometimes. Now coming on, what are the star indications? So for main rotablation, the most important indication is calcified lesion, undilatable lesion, which are chronic lesions, and sometimes diffuse long lesions, and if needed, then can be done in the instant restenosis. But the limitations are slow flow, no reflow, perforation, and wire bias and dissection, and technically challenging things. So this is how our rotablation to start with, just to think in our mind that once there is a lesion, what we normally do in an PCI, that we take a balloon across it and we dilate it with the balloon. In the similar way, if a fibrocalcific or calcific lesion, then we park the wire, that is the rotawire, across this fibrocalcific lesion, calcific lesion, and over this a rotablation burr is advanced. So this is almost the similar thing, but here the wire is different. This is a longer wire, this is 325 centimeter wire, and it is at the tip it is 0.014, but proximal part is 0.009, and this thicker portion of the wire prevents the burr coming to the distal part of the wire from thin to the thick. So it acts as a barrier. So this is how a rotaburr looks like. The distal part of the burr contains the mainly ablative surface. It has a 20 micron this diamond chips embedded with inside the distal part of the burr, and which has a 4 micrometer protruding from the surface. So distal half of the burr is which is used for the ablation. The proximal half is smooth, and it is a non-ablative surface. Behind it is the drive shaft, and above it there is Teflon sheath, and it is 4.3 French in size. So this is the basic anatomy of the rotablation burr. So first important thing is that how to introduce the rotawire and how to take a burr. So routinely what we do, we take a microcatheter, and in this we take a wire, that is a Burkhorst wire, like run through or Xion blue. Then once crossing the lesion, the microcatheter, as we can see in the figure B, is taken across the lesion, and then the wire, PTCA wire, run through wire or Burkhorst wires is taken back, and in this microcatheter then a rotawire is crossed, and over this the rotaburr is advanced in a proper fashion. So this is how. Sometimes if the lesion is very critical, then we may sometimes directly need to negotiate the fibrocalcific, the calcific lesion by the rotawire itself. But many times it is difficult because it is difficult to manipulate this wire. So how does this rotablation work? So just keeping the way we do the shaving, the blade is there, but It cuts the hairs, not the skin. So there is a differential cutting mechanism in this. This rotaburr cuts the more rigid structure and more inelastic material and not harming the soft or the elastic material. And there is orthogonal displacement of the fraction as well. So this is how main the console of the rotablation system is. This is the older version. I would be discussing the RotaPro in the next session. So this is a gas supplies which contain monitor gas that contains in tank. There are monitors. There is a gas cylinder which contains nitrogen or air, and it gives a pneumatic pressure to rotate the burr. And there is in the conventional rotablation there is a foot pedal which has two pedals. One is dynaglide button, that is the mode for the lesser speed when we withdraw the burr, that is around 60 to 80,000 to 90,000 RPM. And the other one, the pedal, is the pedal for main increasing the speeds of the rotablation. Once we do the rotablation at 140 to 160,000 RPM, and we can go ahead. And this different button is for the dynaglide mode. And this is the console which shows there are places where we can see the speed of the burr, and we can see this fluorescent light coming up when we are doing the dynaglide button on. And there is a procedure timer. We can see for how much time we are burring. And these are the place where this air turbine is connected or the pneumatic connector is connected. And when the places, this is a place where we see the speed of the burr also. So the rotor speed, burr speed can be seen on the display, that is called a tachometer, and the fiber optic cable are connected from the this advancer to this console. So this is how a rotablator advancer looks like. So it is a conventional rotablation advancer. In distal part, it has a drive shaft, and it is a drive shaft connector, and this is the body of the advancer, and there are three ports. One is for saline. There should be continuous saline infusion. One is the fiber optic cable which is connected to the tachometer, which measures the speeds of the rotablation burr. And the third one is the compressed gas connector, through which the pneumatic pressure this rotates this burr. And in the distal part of this, we have a brake defeat button, and we also have a exit for the guide wire, rotor wire, and over this we can apply a wire clip torque. So this is a convention, and this is the advancer knobs. It moves forward and backward. So once we are moving the burr inside, it will move forward, and if we are moving it back, then it will move backward. And once we are taking the burr, we'll rotate this, we'll make it this lock at the 2/3 and the 1/3 junction, leaving the two-finger bed behind. Because once we are inside, many times we need to move remove the tension, and for that we have to remove the lock, and we have to move it forward and backward, and also can press the dynaglide button to remove this tension in the rotor wire. So these are the various sizes of the burr, and it's most commonly used are 1.25, 1.5, and sometimes 1.75 or 2 millimeter. And the most important thing is that up to 1.75 millimeter burr, we can use a 7 French guide, and for the most of the cases, 1.25 and 1.5 burr can be used in the 6 French guide. So this is very important, that majority of the cases, because now we are not using a debulking, we are using a black modification technique, and we can go even up to the 0.6 or 0.5 ratio of the artery. Suppose we are taking a 3 artery, it is calcified, then we can take a 1.5 burr, and for this 6 French, even the radial route can be good. So this is how, again, about the rotor wire. The rotor wire is 325 centimeter wire available into floppy and extra floppy. For this majority of the lesion, floppy wire would be good. And in this, there are subtle differences that I'm not going to the detail, but for ostial or distal lesion, extra support wire is used, and for most of the lesions, this floppy wire would be good enough. So the remarkable difference as compared to the other PTCA wire is that this proximal part of the wire is 0.009, whereas the distal tip, which contains the spring tip, it has a 0.014, platinum tip. So it prevents the burr coming from the distal part to the last part of the wire. So it prevents migration of the burr. So there are few important mnemonic that should be kept in mind. One is drip, rotate, advance, and wire. So this is a draw mnemonic. In this, what does it stand for? We see once once the rota wire is parked across the lesion, then we should see before starting the rotablation, we should connect the saline and we should check the machine whether the saline is dripping from the bottom of the advancer or not, and the catheter, and rotate, R stand for rotate, whether the burr is rotating and RPM are stable, and we can check on the this display where it is shown what is the rotation speed of the burr. And advancer, we should move the advancer knob back and forth movement, front and back. We can see whether the movement of the knob is free or not. And wire, whether wire is visible across the distal port of the advancer, and whether the wire is brake is functioning properly or not. So this is how we can, once the saline hypernized saline is connected, we can see whether the on moving on whether the saline drops are coming out of this catheter, and whether this by increasing the speed, whether this flow is increasing or not. Then we should check the speed, and we can see on this console while rotating the knob, we can increase the speed. And usually the most commonly used speed is 140 to 160. Many times we can also need to increase the speed up to 2 lakhs, but for larger bird, it should be lesser. And this is how we should see whether advancer knob is moving freely in front and backward or not. And we should apply the wire clip torquer and see whether this wire is functioning, this brake is functioning adequately or not. So once we are done with this, then we can, most of the cases we choose a Lassen modification as compared to the debulking, in which the burr RT ratio is less than 0.7, around 0.5 to 0.6. So these are the how. On the right side we can see the movement of the burr. Once we take the burr till the tip of the guiding, then we can move it to the ostium of the artery, and we see we should avoid the very rapid movement of the burr. It should be slow, gentle, and smooth. So, and we should avoid burring in the catheter, and it should be a packing motion. We should start, hit, and come back. We should start, hit, and come back. So we should go, hit, and come back. That should be always in our mind. So the burr is moved forward and backward in the lesion, and this burr should never stop inside the lesion. That has to be kept in the mind. It should not stop beyond distal to the lesion, and it should not stop in the lesion. And once we see auditory that the pitch changes, and we can see visually that the burr has crossed the lesion, and we can feel the this auditory pitch changes, and we can also visualize that whether the burr has crossed the lesion or not. So this is how, but never stop. On the right side, we can say we should never stop in the mid of the lesion or distal to the lesion, because there are chances of stuck burr. And we should finish with the polishing run, and there should be no significant drop in the RPM, not more than 5,000 drop for more than 5 seconds. So the burring should be of short duration, usually less than 20 seconds, and we should give a brief period for resting, just for the perfusion to settle. We should stop after burring for 3 to 5 seconds. We can, after this packing motion, we should rest the burr for 3 to 5 seconds to provide the reperfusion. And drops more than 5,000 should be avoided. And for the lesser burrs, I've just discussed that 160 to 180 speed is good, but for greater more than 2 millimeter burr, speed should not be that high. It should be between 140 to 160,000 RPM. And again, to reiterate that very rapid advancement or daughtering should be avoided, and avoiding or stopping the burr in the mid of the lesion should be avoided. And we should explain our technologies that not to adjust the RPM while we are ablating. So I think this was a brief discussion about what the technique of the rotablation is, and now we have a good Rota Pro in which all the controls which were available in the foot now are available to the one console, and that can be done via our hand only. So most of the controls have come in the hand, and we have a sophisticated instrument Rota Pro available, and it is a only bit different. It is not markedly different, but it is very good or user friendly, and it saves our time. So for Rota Pro, I would be discussing in the next session. Thank you.